I'm Dr. J. Glory, Associate Professor of Physics, Institute of Aeronautical Engineering. Today, I wish to tell about the topic physical significance of a wave function. What is physical significance of a wave functions? Here, we are going to discuss about the topics wave function, probability of finding a particle, normalized condition, orthogonal wave function, and then orthonormal wave function. These are the topics we are going to be covered here in this session. So first of all, we shall see about the what is wave function. So if there is a wave associated with a particle, then there must be a function to represent it. If there is a wave which is associated with a particle, then there must be a function to represent it. So this wave function is this is the wave function. That is, this function is called wave function. So we are taking a matter wave. So if a wave is associated with a particle, then there must be a representation of wave function. So that is called wave function. Okay. So the wave function associated with a moving particle is not an observable quantity and does not have any direct physical meaning. So it is a complex quantity. So a wave associated with a particle have a function to represent that matter wave. So that function is called wave function, and this wave function associated with a moving particle which is not an observable quantity. It is not an observable quantity and does not have any direct physical meaning. So it is a complex quantity. It is a complex quantity. So wave function is defined as a quantity. Wave function is defined as a quantity whose variations make up matter waves. It is represented by a Greek symbol spelled as psi. So psi consists of real and imaginary parts. It consists of, that is, this wave function consists of real and imaginary parts. So consider a particle. Considering a particle having three-dimensional motion along the three coordinates x, y, z. Considering a particle having three-dimensional motion, so along the coordinates x, y, and z. So the value of wave function psi associated with a moving particle at a point x, y, z in space is related to finding of the particle there. So since the wave function is a complex quantity, it may be expressed in the form psi of x, y, z, t is equals to a plus I. Okay, so the wave function is a complex quantity. It may be expressed in the form of x psi of x, y, z, t is equals to a plus ib. So where a and b are real functions of the variables x, y, z, and t, and I is imaginary one. So I is equals to root minus 1. So the complex conjugate of the wave function psi is given by psi star of x, y, z, t is equals to a minus ib. So the value of wave function psi associated with a moving particle at a point xyz in space is related to finding the particle there. The value of the wave function psi associated with a moving particle at a point xyz in space is related to finding of the particle there. So the probability of finding the particle, the wave function psi itself has no physical significance. The wave function psi itself has no physical significance, but when it can be signified, the square of its absolute magnitude, modulus psi square, has the significance. So when it is significant, so when it is squared of its absolute magnitude. Okay, so the wave function psi itself has no physical significance, but the square of its absolute magnitude, modulus psi square, has physical significance. When modulus psi square is evaluated at a particular point and at a particular time, then then it gives the probability of finding the particle there at the time. When modulus psi square is evaluated at a particular point and at a particular time, so then it gives the probability of finding the particle there at that position at that particular time. So the complex wave function can be represented as psi of x, y, z, t is equals to a plus ib, and complex conjugate is psi star of x, y, z, t is equals to a minus I. Here we are taking the product of both the wave functions. So the product of wave function and its complex conjugate is psi of x, y, z, t into psi star of x, y, z, t is equals to a plus ib into a minus I, as psi of x, y, z, t is equals to a plus ib, and complex conjugate of this wave function is psi star. So psi star x, y, z, t is equals to a minus I. So when taking the product, psi star is equals to psi of x, y, z, t to psi star. So psi star is equals to psi of x, y, z, t to psi star x, y, z, t. So the value of psi star is a plus ib into a minus ib. So let P is the probability of finding the particle. So capital P is equals to psi star is equals to the product of the functions, wave functions, psi of x, y, z, t to psi star x, y, z, t. So modulus psi of x, y, z, t square is equals to a square plus b square. As here a plus b, so a into a and then plus a IB minus A IB plus I square B square. That is IB to minus I. So it is equals to A square. This both will be cancelled. So plus here minus I square B square is equals to A square. So here I square value is minus 1. So plus B square. So we'll get the value A square plus B square, which is the value of probability density capital P, that is equals to psi star. Psi star is equals to A square plus B square. So it is a real quantity. This is a real quantity. So thus the product of psi and psi star is real and positive. If psi is not equals to 0 and is known as probability density of the particle associated with the de Broglie wave. So the product of psi and psi star is a real and positive if psi is not equals to 0 and is known as probability density of the particle associated with the de Broglie wave. When the motion of your particle when the motion of your particle is confined when the motion of the particle is confined to a volume element dV, then the quantity becomes as PdV, that is a small volume element. What is the probability density of the particle there in that particular volume of that element? So PdV is equals to psi of xyzt into psi star xyz t dV. So that is equals to modulus psi of xyz t square dV. So this is the expression for the finding the probability of the particle which is confined to a volume element dV. So this expression is the probability of finding the particle in dV surrounding the point at xyz. So in all the three coordinates. So for the motion of your particle in one dimension, the quantity. So if the particle is in one dimensional, so we are taking x. So the probability density, the probability of finding the particle at the x coordinate in the x dimension. So p dx is equals to psi of xt into psi star xt dx. So it is equals to modulus psi of xt square dx. So it is the probability of finding the particle over a small distance dx. Finding the particle probability over a small distance dx. So normalized condition. So the probability per unit length of finding the particle at position x at time t is p is equals to psi star xt into psi xt. So probability of finding the particle in length dx is p dx is equals to psi star of xt to psi of xt dx. So total, what is the probability of finding the particle? So the total probability of finding the particle somewhere along x-axis. Somewhere along x-axis is integral dx is equals to integral psi star xt into psi of xt dx. If the particle exists, it must be somewhere on the axis x. So the total probability of finding the particle must be unity. So that is integral psi star xt into psi of xt dx is equals to 1. So this is called the normalized condition. This is called the normalized condition. So a wave function psi of xt is said to be normalized if it satisfies the condition 1. So that is the condition 1 is, so integral psi star xt into psi of xt dx is equals to 1. If the wave function is said to be normalized, so this expression is equals to 1. So orthogonal wave function. So consider two different wave functions. Different wave functions that two different wave functions are psi m and psi n. So such that both satisfies the Schrodinger equation. So both the wave function satisfies the Schrodinger's wave equation. So these two wave functions are said to be orthogonal if they satisfies the conditions. If they satisfies the conditions. So what are the conditions? So integral psi star of xt psi xt dv is equals to 0 for n is not equals to n, or integral psi star of xt into psi of xt dv is equals to 0 for m is not equals to n. If both the wave functions are simultaneously normal, if both the wave functions are simultaneously normal, then integral psi m into psi m star dv is equals to 1, as well as it is equals to integral psi n star dv. So coming to the orthonormal wave functions, the sets of wave functions which are both normalized as well as orthogonal are called orthonormal wave functions. The sets of wave functions which are both normalized as well as orthogonal, then those are called orthonormal wave functions. So integral psi m star psi n dx is equals to 0. That is, if a particle is in the state psi m star of x, then particle cannot be in the state which is in the wave function psi n of x simultaneously together. So this is the probability of finding the particle. So what are the topics we have covered here? So wave function and probability of finding a particle. Then we have seen that what is normalized condition. So if the expression is equals to 1, then we can say that it is normalized and the particle is in that particular wave. And then orthogonal wave function, finally orthonormal wave functions. So here in wave function, so wave, if a wave associated with a particle, then surely it represents with a function. So that function is called wave function. So a wave function associated with a particle, moving particle, it is not an observable quantity and does not have any physical significance. So it is a complex quantity. So that wave functions is defined as a quantity whose variations make up matter waves. So it can be represented, the wave function can be represented by psi, which is a Greek symbol. And then we have taken the particle is in the three coordinate system. So then we can represent the wave function psi of x, y, z, and t. So we have taken the wave function complex and complex conjugate, and then we took the product. So as we have taken, it is a complex quantity, so that the wave function associated with a moving particle is not an observable quantity and does not have physical meaning. So it is a complex quantity, so that we are going to take the product of the complex quantity and then its complex conjugate. So that we are taking probability finding the particle P is equals to psi star. So it is equals to a square plus b square. So this a square plus b square is a real quantity. So when taking the product psi star, we get the real quantity. So the product of psi and psi star is real and positive if psi is not equals to 0, and is known as probability density of the particle associated with the de Broglie wave. So and then we took a small volume of dV. So what is the probability of finding the particle? So PdV is equals to modulus psi of x, y, z, t square dV. But when we take in single dimension, so we are taking the particle which is moving in one dimension, then the quantity p dx is equals to modulus psi xt square dx. Okay, so this is the probability of finding the particle over a small distance dx. So then normalized condition. So in this normalized condition, the expression which satisfies integral psi star xt psi of xt dx is equals to 1, then we can say that it is a normalized condition. So that is that if the particle is exist in the wave, then it must be somewhere on the x-axis. So the total probability for finding the particle must be unity. So this is called the normalized wave function. And orthogonal, and finally we have seen that orthonormal. So orthonormal is nothing but the sets of wave functions which are both normalized as well as orthogonal. Then it is called as the orthonormal wave functions. So here integral psi star into psi dx is equals to 0. So that is what we can say. If a particle is in the state of psi star x, then the particle cannot be in the other wave function, that is in the state of psi of x simultaneously together. So means that if the particle is in the state of psi star x, then it not be in the psi of x. So if the particle is in the wave function psi of x, then it could not be in the other state of psi star x. So that is orthonormal wave functions. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.